Welcome students. So far we have discussed about the pure substances and the mixtures. Now today we will discuss um, solutions, suspensions and colloids. And before we discuss solutions, suspensions and colloids in detail, we should know the meaning of the two terms, solute and solvent. What do we mean by solute? So let me tell you students, the substance which is dissolved in a liquid to make a solution, it's called solute. And the liquid in which solute is dissolved, it's called solvent. So for example, if we are making a solution of salt, so how we will prepare the salt solution? We'll dissolve salt in water, right? So salt here is solute because we are dissolving salt, right? So substance which is dissolved, that is called solute. So salt is solute and we are dissolving it in water. So water is nothing but solvent, because solvent is the liquid in which solute is dissolved. Okay, the one which is dissolved, it's called solute, and in which the solute is dissolved, it's known as solvent. So salt is the solute and water is the solvent. Similarly, if we are having substances like sugar, ammonium chloride, copper sulfate, which are dissolved in water to make solutions, so they are called solutes, and water is the solvent. And usually, what happens, the substance present in lesser amount in a solution is considered the solute, but it's not always. Usually it happens like lesser amount in a solution is considered as the solute, and the substance present in greater amount in a solution, it's considered the solvent. And yeah, solute particles are also called dispersed particles. Okay, and solvent is also known as dispersion medium. Now, today we are going to discuss solutions and suspensions and colloids, which differ actually in the size of solute particles and the size of dispersed particles. And we'll discuss all the three in detail one by one. So, let's start with the solutions. What is a solution? Actually, all of the three, solution, suspension and colloids, these are actually the mixtures, right? So if we talk about solutions, solution is a homogeneous mixture of two or more substances. Homogeneous mixture means you know that the mixture is same throughout. We have discussed homogeneous mixture, right? So solution is a homogeneous mixture of two or more substances. So the examples of solutions can be salt solution, sugar solution, vinegar, metal alloys, air. These are all the homogeneous mixtures, so that is why they are termed as solutions. Let's look at salt solution. Salt solution, you know, it's a mixture of two substances, salt and water, right? Suppose sugar solution. It's again a mixture of two substances, sugar and water, and both these mixtures, salt solution, sugar solution, these are homogeneous mixtures because you cannot have the visible boundaries there. Particles are completely dissolved, it's uniform throughout. The mixture is uniform throughout, so that is why it's salt solution, sugar solution, these are homogeneous mixtures, and in fact they are known as true solutions. Why true solutions? Because in these solutions, particles of salt and sugar are mixed so well with water that we cannot distinguish one from the another. And true solutions are also known as molecular solutions. Again, because the size of dissolved particles, size of solute particles is same as that of a molecule. So that is why molecular solutions. Okay. And in this chapter, when we talk of a solution, it will mean a true solution or a molecular solution. So we are having a lot of examples of solutions: copper sulfate solution, alcohol and water mixture, petrol and oil mixture, soda water, in fact, soft drinks, In fact, the lemonade, which is a drink made from lemon juice, right? That is also a homogeneous mixture. That is also called solution. So the substances which dissolve in water completely, like salt is getting dissolved in water, sugar is getting dissolved in water, these are said to be soluble in water. Okay, those substances which dissolve in water completely are said to be soluble substances. And only soluble substances form true solutions, because only there you will have you cannot distinguish one from the another, because the particles are mixed so well. So only soluble substances form true solutions. So copper sulfate, that is also soluble in water. So it when copper sulfate dissolves in water, it will form copper sulfate solution. So it's again true solution. Okay. Now, types of solutions. We usually think that solutions are formed when solid substances are dissolved in liquids, right? When sugar is dissolved in water, salt is dissolved in water, so we are dissolving solid in liquid. So we usually think that solutions are formed only when solid substances are dissolved in liquid. Though most of the common solutions are made by dissolving solid in liquid, but this is not always so. In fact, solutions can be made by dissolving solids in solids, by dissolving solids in liquid, by dissolving liquid in liquids, by dissolving gases in liquid. In fact, by dissolving gas in a gas, we can have a solution. So, as long as the mixture is homogeneous, solution term is applied there. Your mixture is solution, okay? As long as the mixture is homogeneous. Now, the various types of solution is when you are having solution of solution in liquid solution. Okay, when you are having solution of solid in liquid. Okay. Now, this is the most common type of solution, as I told you, like sugar solution, salt solution. These are the solutions of solids in liquid. In fact, solution of iodine in alcohol, that is also a solution of solid in a liquid, because iodine is solid and it's mixed in alcohol. Alcohol is a liquid. So this solution of iodine in alcohol, it's called tincture of iodine. Okay, and it's again a solid in a liquid type of solution, because it contains a solid iodine dissolved in a liquid alcohol. Okay. Then we are having another type of solution, that is solution of solid in a solid. Now see, metal alloys. Alloys are the solutions of solid in solids. For example, you are having an alloy brass. Now we know that brass is actually a solution of zinc in copper, right? So brass is prepared by mixing molten zinc with molten copper, and then cooling their mixture, and we will get a solution of brass. So here zinc and copper both are solid. So we have prepared this type of solution by mixing solid in a solid. Okay, this is another type of solution. One more is there, that is solution of gas in liquid. Now, solution of gas in liquid, we are having soda water, we are having aerated drinks there. That is actually a solution of carbon dioxide gas in water. So see, it's gas in a liquid type of solution, right? One more is there, we are having a solution of gas in gas. So the best example there is air. Air is a solution of gases like oxygen, nitrogen, argon, carbon dioxide, water. Sorry, not nitrogen, because nitrogen is actually the largest, the one which is present in the very large amount. Nitrogen is present in very large amount in air. So it's actually air. It's a solution of oxygen, argon, carbon dioxide, water vapor, etc. in nitrogen gas. So here nitrogen gas is the solvent in air, and all other gases are solutes. So gas is getting mixed with the gas. So solution of gas in a gas. Okay. One more is there, that is solution of a liquid in a liquid. There you can have vinegar. that is solution of liquid in liquid. So here vinegar is the best example of this, because you know in vinegar we are having actually acetic acid in water, right? So acetic acid is a liquid, water is a liquid, so solution of liquid in liquid type of liquid, right? So this is a liquid in liquid type of solution. Now let's discuss the important thing of solution, that is the properties of a solution. Important characteristic properties of a solution are like, first one is solution is a homogeneous mixture. It means the mixture is homogeneous, mixture is same throughout, it has no visible boundaries. Okay. Second property is that the particles of solution are so small that they cannot be seen by naked eye. It means the size of solute particles in a solution is extremely small. It's actually less than 1 nanometer in diameter. Okay, when 1 nanometer is equivalent to 10 raised power minus 9 meter. So basically, size of solute particles is very small, very less. So that is why they cannot be visible by naked eyes. They cannot be seen by naked eyes. And one more property is that the particles, we cannot see them by naked eye. Even we cannot see them with a microscope also, because particles are having a size of less than 1 nanometer. Okay. Another characteristic property is that the particles of solution do not scatter light. So whenever light passes through solution, it does not show the path of a light. Its path of light is not visible whenever a beam of light gets passed through a solution. Why the path is not visible? Because the particles are very very small, that they are not able to scatter the light. They are not able to make the path of light visible because they are small. So that is why they do not scatter a beam of light. Another property of solution is that the solutions, particles of solution, they can pass through the filter paper. That means you cannot separate the constituents of the solution by filtration. We cannot separate the solution by filtration because particles are small, so they easily pass through the filter paper. We are having one more property of solutions, that is solutions are stable. Now, what do we mean by stable? Stable means that the particles present in a particles of solute which are present in a solution, they do not separate out on keeping, they do not settle down, they do not remain suspended, because they are actually so small and soluble. That is why they do not remain suspended, they do not get separate out from solution in if we keep them undisturbed for some time. So that means solutions are stable, particles do not separate out on keeping. So this was all about the solutions.